Welcome to this walkthrough of the Monday version of the second exam for Philosophy 120. Let's jump right in. Explain the difference between primary and secondary qualities. This one was handled a little bit lazily by folks. This is a philosophy class, and you need to develop an ear for which terms really need some explication and explanation. The main one here that needs some attention is the notion of what it is for something to be real. Primary qualities do not depend for their existence on anything about us. Secondary qualities do. So, to say that roses are red is to say they look red to a typical human observer under normal conditions, something like that. A lot of you tried to capture that by saying something along the lines of primary qualities are real and secondary qualities are not. I see why you did that. Galileo and Descartes don't think that redness is really out there, as it were. But that's really not an adequate way of formulating it. I gave you considerable partial credit, but it's not going to do the trick. Subarus depend for their existence on human beings, but they are both real and out there. So the mere fact that something wouldn't exist if it weren't for us has no tendency to make it unreal. So really the issue is about something more like independence than it is reality. Subarus depend for their existence on us, but it doesn't make them unreal. So it's not that Descartes and Galileo think that redness is unreal exactly. It's just not fundamental. It is not independent of us and our apparatus in the way that we think it is. So an adequate formulation would be, again, something along the lines of primary qualities are in the object independently of any human observer. Secondary qualities are products of the interaction between human observers and our sensory apparatus on the one hand, and the primary qualities of the object on the other. Less partial credit was able to be given on number 2, just because a lot of people who answered it didn't seem to have the relevant facts at their disposal. You got to start by understanding the problem you're trying to solve. If Venus is the second planet coming out from the sun and Earth is the third planet, and they are orbiting at different rates around the sun, all of which are fundamental components of the Copernican view, then Venus should sometimes be relatively close to the Earth and sometimes relatively far from the Earth, and you would expect a variation in brightness of a factor of about 40 when you do the math based on the distances. It's well known that Venus does not exhibit hardly any variation in brightness, much less a factor of 40, and so this was very solid empirical evidence against the Copernican view until Galileo busts out his telescope and sees phases of Venus. You didn't have to explain why Venus exhibits phases. You could, but you didn't have to. It's for the same reason the moon exhibits phases. The idea is that the phases of Venus counteract the expected variations in brightness based on distance. When Venus is quite close to us, we are, and you can work this out geometrically, only able to see a crescent. When Venus is quite far from us, we are able to see the full face of Venus. And so the phases neutralize the counter evidence. And in fact, the phases, once directly observed, provide powerful evidence for the Copernican view. So really, Galileo did two things. He used the phases of Venus to counteract the evidence against the Copernican view, because there's no perceived variation in brightness, and the very evidence that counteracts that apparent counter evidence is also positive evidence for the Copernican view. You didn't have to say it in that kind of detail, but you had to get in that ballpark. Number 3 is partially on me that it wasn't a more successful question. I think when I've had more time with students, I've been able to use this formulation to convey what I was looking for, and it didn't go as well in this hybrid version. The thought experiment of Galileo's I had in mind is the frictionless ball on a frictionless surface, which he uses to convince Simplicio of the equivalence of rest and constant velocity motion. As I read the dialogues, the stuff about the ship and dropping a ball from the mast is really a consequence of this other thought experiment. It's closer to a conclusion than it is an argument itself, but I can see how it could be read as if that's the direct thought experiment. And so my question was not as clear as it should have been. I tried to be quite generous with partial credit because I don't think, for the most part, you can be blamed for not understanding what I was looking for there. They amount really to the same thing, which is that constant velocity motion has no effects that are discernible. When I underline exactly, that's a warning to you to be careful about how you formulate something. So it's not going to be enough to just talk of something like we can't prove that the sun will come up tomorrow. That's not Hume's claim. That does not do justice to how radical a claim Hume is making. His answer to the question of how justified it is to think the sun is going to come up tomorrow is not at all. That belief is utterly without rational foundation. It is no more justified to think the sun is going to come up tomorrow than it is to think it won't. Nevertheless, and here's where the exactly stuff is supposed to come out, it is false to say that we shouldn't believe the sun will come up tomorrow. For one thing, we can't help it, and so should is really out of place here. You're going to believe the sun is going to come up tomorrow because the world has conditioned you to believe it. And in any case, it's not like you'd be better off from the standpoint of rationality or navigating the world to think the sun won't come up tomorrow. So Hume's official view is lots of beliefs on which we depend are utterly without rational foundation, but it's not the case that we should refuse to believe them because they're without rational foundation. What is the case is we should get over this myth, Hume thinks, that the only thing that supports a belief is rationality. These are beliefs that are irresistible, and though they're irrational, they're unimprovable. So we should just acquiesce in the fact that we're not as rational as we'd like to think. Hume's counterfactual analysis of causation is one of his two analyses of causation. The regularity analysis, which you were not asked to present here, says to say that A causes B is to say A-type events are invariably followed by B-type events. The counterfactual analysis says to say that A caused B is to say, had A not happened, B wouldn't have happened. So you need to get that counterfactual analysis in there. You need to be able to distinguish the counterfactual analysis from the regularity analysis. Why does this have this untoward consequence? Well, if Jones hadn't eaten the arsenic, he still would have died because he would have been hit by the bus. So it doesn't look like the arsenic killed him. Had he not been hit by the bus, he still would have died, so it doesn't look like the bus killed him. So a more sophisticated counterfactual analysis would say the arsenic killed Jones if, and only if, had he not eaten it, he would have died at a somewhat different time or in a somewhat different manner, something like that. But we're only dealing with simple counterfactual analyses here. Corpuscularianism is the genus. Atomism is a species of that genus. Corpuscularianism is the hallmark of the so-called new philosophies that arose in the 17th century. They try to explain everything in terms of matter in motion. Atomism is that particular flavor of corpuscularianism, which adds to generic corpuscularianism the claim that there are indivisible units of matter floating around in a void. Ideally, you would have brought out both of those elements of corpuscularianism, both of which are denied by Descartes. Descartes thought matter was infinitely divisible, and he denied the existence of a void, so he is a corpuscularian, but not an atomist. Leibniz's relationism about space and time says that space and time are relations or relationships, not things. Cousinhood is not a thing, but it's a real relation in that you either do or don't stand in that relation to various people. Likewise, space consists of spatial relations like distance. Time consists of temporal relations like preceding, succeeding, and being simultaneous with. So just as we don't want to thingify convenience in a convenience store, it's not a noun, it's like an adverb. Space and time are relations that things bear to one another, not things. That's roughly what I mean by explaining the view, not just sort of quoting some formulation of it you got. What's the biggest problem his view faces and why? Folks were not as solid on this as I would have liked. It looks like his view has the consequence that we can't make sense of times when nothing happens or places where nothing is, because there is no distance between two nothings. Leibniz tries to handle that by saying we can make sense of possible distance relations. We don't need to just talk about actual distance relations. We could understand cousinhood by talking about what it would be for Barack Obama to be your cousin, something like that. The danger is that it's slipping pretty close to Newton's view when we talk about these possible spatial or temporal relations. It looks like there needs to be something fairly stuff-like that grounds these possible relationships. So it's not clear that Leibniz can preserve his relationism if he's going to allow possible relations, not just actual relations. Newton's absolutism gets in similar amounts and kinds of trouble, but let's understand it first. Absolutism says that space is a propertyless quasi-container of objects, and time is a propertyless quasi-container of events. You don't have to use this quasi-container talk, but you need to get across this idea that these are things which have no discernible features. That's the heart of Newton's absolutism. That's what's weird about it. Space would be just as it is if there were no objects in it. Time would continue marching on even if there were no events, no objects, no changes to mark time. The biggest problem Newton's view faces is it commits us to scientific facts which are in principle unascertainable. There is no experiment that reveals the existence of propertyless space or time, at least according to Leibniz. There's no such experiment. Leibniz brings this out theologically. God could have created the universe either earlier or later, and it would go just as it has. God could move the universe an arbitrary distance in absolute space, and things would still be just as they are. And so Leibniz says any alleged scientific fact which is in principle unascertainable or unobservable isn't an actual scientific fact. Newton tries to solve this by bringing in the distinction, which is coming back now that we're at Einstein, between constant velocity motion on the one hand and accelerated motion on the other. He grants to Leibniz that constant velocity motion with respect to absolute space has no observable consequences. He tries to argue that accelerated motion with respect to absolute space has observable consequences. You feel forces when you accelerate or come to a stop. It's not clear that that's a successful argument. If you slam on the brakes on your car, you feel forces and you're coming to a stop. It's not obvious that you're accelerating or decelerating with respect to absolute space rather than Earth or the center of gravity of the Milky Way galaxy or something like that. So it's complicated. I didn't really care whether you took Newton's side or Leibniz's side, but I wanted you to show me that you understand how their views work. The law of inertia is first formulated by Descartes. Newton takes it from him, but it's essentially Newton's first law of motion. Objects at rest tend to remain at rest. Objects in motion tend to continue moving in a straight line, in both cases, unless acted on by an outside force. Descartes derives this a couple ways. The one we talked about is theological, so you needed to work through the main parts of that argument. God is the source of all motion, God is unchanging, and God is perfect. So the amount of motion in the universe is unchanging, and a straight line is the simplest, most direct, most perfect way for things to move. And so, because motion derives from God, it has this property of being inertial. So Descartes is using a version of the method of hypothesis. Here, a hypothesis is not a guess. That is more Christian Huygens' version of the method of hypothesis. Descartes works out in advance by going back to basic, allegedly incontrovertible features of the world. Talk about what God is, what matter is, what motion is, what a vacuum is. You work out these basics, and only then do you apply them to observation. This contrasts starkly with Newton's inductivist methodology, where we notice patterns and we project them as far as we can as long as they continue to hold up. So, Newton argues on behalf of universal gravitation by saying it is as if there is a terrestrial force that accounts for the motion of projectiles and various other kinds of motion. It is as if that same force accounts for the moon's orbit around the Earth and the tides. It is as if that same force accounts for Kepler's laws of planetary motion. Since it is as if this force operates everywhere, let's say that force operates everywhere. And so that's an inductive approach. Descartes has a kind of a priori approach. You work things out before you engage in observation so that you have certainties on which to ground observation. So, laws of nature for Descartes are fundamental truths about things like matter and motion derived from their very natures or the nature of God, that kind of stuff. How do you figure out what they are? By reflecting on the concepts involved. Descartes thinks the notion of nothingness and the notion of space together rule out the possibility that there could be a void or vacuum. Right? If there were nothing in between two things, they would have to be touching. That's an example of Descartes' attempt to reason out in advance the fundamental features of physics. What does Newton think is wrong with Descartes' approach? This attempt to get certainty in advance nevertheless did not prevent Descartes from making mistakes. So what Newton learns from this is you're not going to be able to grasp the essences of these things. All we're going to be able to do is locate patterns and push them as far as they can. And so Newton thinks the inductivist approach is safer, that the human mind is not in a position to get as ambitiously behind experimental phenomena as Descartes thought. What weaknesses would Descartes find in Newton's approach? He thinks you can't ground Newton's laws on the kind of bedrock certainties that we need. Descartes would have loved Hume's skepticism about induction as a way of resisting Newton's inductivist approach, though Hume thought he was supporting Newton's inductivist approach. That's some interesting stuff, but it's not part of this question. All right, hopefully that shows you where you went wrong, in my eyes anyway. If you have any questions, feel free to contact me. Thanks for your time and attention.